Welcome to lesson number 2. We're going to be using our trig ratios, but specifically we're going to be using the calculator function and our trig ratios together. So in the previous lesson we looked at these two examples, and with these two examples we also looked at the mnemonic SOHCAHTOA. And just a reminder, the sine ratio is opposite divided by hypotenuse, the cosine ratio is adjacent divided by hypotenuse, and the tangent ratio is opposite divided by adjacent. SOHCAHTOA. Now, when we're using our calculator, we can find these ratios with 4 decimal places and more. Usually, with answering these questions, it's going to ask for 4 decimal places. So with this first example, what we're going to be doing is we're going to be using the trig function, so in this case tan 35 degrees, to find our ratios. And what we're going to find is that our ratios are going to equal, when I type in tan 35.7, and then when I type in tan 58, it's going to equal 1.6. So with 4 decimal places, tan 35, I type in my tan button, which is right here, tan, and then I type in the angle, 35, and I should get an answer of 0.7002 to 4 decimal places. So 0.7002. Now, if you're getting a different answer, one of the reasons could be that your calculator is in the wrong mode. And so if it is, if you have a Texas Instruments TI-30X 2S, then what you got to do is go into your degrees and make sure that it's not in radians. So another answer you might be getting is this one, which is not the correct answer that's not the answer we're looking for. And if that's what you're getting, then you want to make sure your calculator is in degrees and not radians. So degrees, again, we would type in tan 35, press enter, and I get 0.7002. If I type in tan 58, I get 1.6003 if I include my 4 decimal places. Now, with class example number 1, we want to use a calculator to determine the values of each of the trig ratios. So with sine 35, I get a value, and we want to include 4 decimal places. So here I get 0.5735, but because I have a 7 there, I'll round that up to 36. With cosine 35, I get 0.8192. Again, there's a 5 there, I'll round up. With sine 58, I get 0.8480. So 0.8480. And lastly, cosine 58 would give me 0.5299. So the diagram below show triangles similar to the ones on the previous page, in which the 2 hypotenuse are equal to 1. So my hypotenuse is 1 here and 1 here. As the angle AOB, so AOB was referring to this angle and this angle, increases from 35 degrees to 58 degrees. Explain using SOHCAHTOA why the sine ratio increases in value, but the cosine ratio decreases in value. Now, before we begin, what we want to determine is, well, what are each of the side lengths? Not the values of our side lengths, but what are their identities? So, as an example, BA, this is my opposite side, and OA is my adjacent side. And same over here, I have my opposite side and I have my adjacent side. So explain using SOHCAHTOA why the sine ratio increases in value, but the cosine ratio decreases in value. So first of all, my mnemonic SOHCAHTOA. And if we're focusing on the sine ratio, which is going to be increasing as we go from 35 to 58, my sine ratio is equal to sine theta is equal to opposite over hypotenuse. Now, 1 is always staying the same, but if we look at BA over 1, BA increases. So for example, this might be equal to 0.5, but here it increases, the length increases. So if this length is increasing, I should call this B1, A1, and B2, A2. And so with my first example, this is from B1, A1, and then we have B2, A2, again, sine theta is equal to opposite over hypotenuse. And that would be equal to B2, A2, also over 1. Now, if we look at B2, A2, so this side over here, this side length is larger. And so since the hypotenuse is changing, or sorry, the hypotenuse is not changing, it remains 1 in both cases. But if we increase this side length here, then we're dividing a larger number by the same value. And so this is going to just get bigger if we keep on increasing the length of this opposite side. But it'll be the reverse for the sine ratio, because if we're increasing this side length, then we're actually decreasing the adjacent side length. So if you look at both these triangles and make a comparison from this point to this point, and this point to this point, my adjacent side on my second triangle got smaller than it was as my sine ratio got bigger, and my opposite side got bigger. So determine what happens to the tan ratio? Well, remember tan, if we look at tan, tan theta is equal to opposite over adjacent. Now, if my opposite side is getting bigger, so this larger number is increasing, and this number here is decreasing, then that means that as my angle gets larger on consecutive triangles, because we're dividing a larger number by a smaller number, check out what happens. So as an example, let's say we were looking at something like this, where I'll just come up with value. Let's say the opposite side was 1 and this side was 2. We got 1 divided by 2. But if I increase my number on the top, so let's put that to 2, and decrease the number on the bottom, and we'll make that 0.5. Then we'll see that our tan ratio also increases. Okay, so if we go from something like this to this, then my tan ratio is going to be bigger with my bigger angle. So state which of the following ratios has a greater value. Well, if I have a sine of 20, this is going to have a bigger value. My angle with a bigger value is going to increase, and if with a cosine ratio, it'll decrease. Out of sine 80, cosine 80, and tan 80, well, without using a calculator, tan 80 is going to end up having the biggest angle, because there's the largest difference between sides and their ratios. Next, we want to use the trig ratios for all angles between 0 and 90 can be approximated using a calculator. So that's my next example. So sine 81. We can approximate that to 4 decimal places. So we're not getting an exact value. That'll be 0.9877 tan 14 is equal to 0.2493, and then cosine 44 is equal to 0.7193. we've discovered that tan 35 is equal to 0.7, tan 58 is equal to 1.6, but is there an angle for which the tangent ratio is 1.2? So here we want to use a guess and check technique to discover the measure of this angle to 1 decimal place. So if I'm looking for my tan ratio, so tan is equal to opposite over adjacent, and I know this because of my mnemonic SOHCAHTOA, and tan, this one here, is equal to opposite over adjacent. So we're wondering if there is a ratio, tan theta, which is equal to 1.2. Now, one way we can use guess and check, well, 1.2, if we turn that into a fraction, right? So 1.2 as a fraction is equal to 1 and 1 and 1/5, 1 and 1/5, which is equal to 6 over 5. I would have to have a triangle that has a length of 6, or in a factor that has a factor of 6 or a factor of 5. So if I were to come up with a triangle that has those measurements and a 90-degree angle, right? So 5 by 6, it's totally possible. It could look something like that, and then something like that. Right? So if this is my angle, then my opposite side would be up here, and my adjacent side would be there, 5 and 6. So use a guess and check technique to discover the measure of this angle to 1 decimal place. So this method is time consuming. Oh, so we want to know the measure of the angle. So tan. So first of all, tan, we want the ratio to equal 1.2. And so if we're equaling 1.2, then using guess and check on a calculator, all you got to do is like type in random angles, right? So tan, let's go like 81 as an example, right? Too big. So tan 60, too big still. Tan, let's go 58. Still too big, right? And so this is guess and check, but there's a better way to do it. We know it's possible. We don't know the angle. We could look at this and think, okay, well, what about tan 45, right? Is 1, so it's got to be a little bit bigger. Tan 50, almost, right? We're just about there. So let's say like tan 50.1. Yeah, still almost there. What about tan 51? 1.2, really close. So this is really time consuming, and that's what this is trying to get at. Like, this takes way too much time just to guess and check, plug things in. So a better way is if we use what's known as the inverse tan function. So if I have this tan ratio 1.2 or tan x of 1.2, then in my calculator, in order to find out the angle, this is what I would do. I would type in tan -1, which is the inverse tan, times 1.2. So whenever you're looking for the angle, you have to use inverse tan. And in order to find inverse tan, you just follow these instructions. You go second function, right here, and then you press your tan button, and you'll get your inverse trig ratio. So tan -1, and then you type in your ratio, which in this case is 1.2, and I press enter, and there is the angle that I'm looking for, 50.19.